Applications of electrolysis. Important applications of electrolysis are electroplating, purification of metals or electro-refining, extraction of metals or electrometallurgy. Click on each application to know more. Electroplating. Electroplating is an electrolytic process by which a thin and compact film of a non-reactive or superior metal is deposited on an article made of a more reactive or inferior metal. Let us now see how an aluminium spoon, which is inferior, is electroplated with nickel, a superior metal. Electroplating is based on electrolysis. The article that is to be electroplated, here the aluminium spoon, is made the cathode by connecting it to the negative terminal of the battery. A pure nickel rod is made the anode by connecting it to the positive terminal of the battery. A solution of nickel ammonium sulfate in water is used as the electrolyte. When a current is passed, the nickel atoms from the anode lose electrons and enter the electrolyte as nickel ions. The positively charged nickel ions are discharged at the cathode by accepting electrons and get deposited as a thin film of metallic nickel on the aluminium spoon. Thus, the aluminium spoon is electroplated with nickel. Purpose of electroplating: protection against corrosion, decorative purpose. Purification of metals or electro-refining. Copper obtained by the reduction of its ore is impure and is called blister copper. By electrolysis, pure copper can be obtained from blister copper. An electrolytic cell is used for electro-refining. In an electrolytic cell, rods of blister copper are used as the anode. An acid solution of copper sulfate is used as the electrolyte. Thin sheets of pure copper are used as the cathodes. When electricity is passed through the cell, copper anode loses electrons to form copper ions. These copper ions go into the solution. Copper ions move towards the cathode and get deposited at the cathode. As copper ions are transferred from the anode to the cathode, the anode gets smaller as the cathode gets bigger. The concentration of the copper sulfate solution remains unchanged. The pure copper sheet gets coated with an increasingly thick layer of pure copper. Extraction of metals or electrometallurgy. The external view of the electrolytic cell used for the reduction of pure alumina is shown here. The cell is called Hall's cell after the US chemist Charles Martin Hall, who invented the process. Hall's cell consists of a steel tank. The tank is lined with graphite, which acts as the cathode. Rods of graphite are suspended into the molten electrolyte and they act as the anodes. The electrolyte is a mixture of molten cryolite and alumina. Electricity is passed through and electrolysis begins. At the cathode, the aluminium ions receive electrons to become atoms. At the anode, the oxide ions lose electrons to become oxygen molecules. Pure metallic aluminium is tapped from the outlet.